everyone, and thank you for joining. We're waiting for a couple of other people to join this session right now, and we'll get started in just a few minutes. And we're super happy to have you here.
Hello, everyone, and welcome to today's webinar, which is a practitioner's guide to computer vision from pilot to production. My name is Chrissy Jameson, and I'm the VP of Marketing here at Viso, and I have the pleasure of looking after you all today. Firstly, apologies for starting just a little bit late. We had a lot of registrations, so we wanted to make sure that we gave everyone the opportunity to get in and get settled. A couple of housekeeping items to cover. Firstly, we will be aiming to run some Q&A at the back end of the webinar, so please feel free to submit any questions to that bar on your right, and Talia will be managing those in the background and helping us work through them. If we do run out of time, if you have left your details, we will make sure to connect directly after to follow up with you. Most importantly, I would like to introduce you to Abby Anderson. Many of you on the call will already know her, but for those who don't, Abby is a technical account manager here at Viso and is responsible for looking after many of our customers and making that magic happen for them. So hello, Abby.
Hi, Chrissy, and hi, everyone. Nice to be here.
Yeah, so I'm super pleased to be able to spend the time with you today. So thank you for joining us. Should we dive straight in?
Let's go for it.
Let's do it. So let's start simple. How would you define computer vision in a way that makes sense across lots of different industries?
Yeah, starting simple, the way that made the most sense to me when I joined Viso was thinking about teaching computers to understand what they're looking at. So teaching computers to see and understand.
It's a great way to be super clear. We're definitely starting to see computer vision become more mainstream. What do you think is driving that shift right now for us?
I think there's a couple of different reasons that it's happening. So on one stance, AI is a massive topic. It's a massive trend. Everyone's talking about it. It's in the news all of the time. And businesses are consciously trying to adopt AI as ways to automate their processes. And they're wanting to make sure they're not getting behind the competitive edge, that they're staying in pace with all of their other competitors around them. On the other stance, what we are seeing from a lot of manufacturers that we work with, large people working in logistics, the manufacturing space, is that they've already invested heavily into camera infrastructure. They've already done CCTV that's covering a lot of their organization and a lot of their plants or facilities. And they're now thinking, we've already made this investment. How do we leverage it to be used for something more? On top of that, hardware costs are coming down all of the time. And as the hardware cost comes down and people's understanding of AI increases, we start to reach this point where smaller problems are able to be solved and things become more feasible. So business cases don't need to be so large, and people can feel more comfortable about trialing AI for whatever, or trialing computer vision for whatever problem it is that they're trying to solve.
Nice. Yes. Yeah. So you touched up there on computer vision as a form of data collection. Can you unpack that, what that means a little bit more for me?
Yeah. So one of the challenges that we still see most prevalently is that people think that computer vision is going to solve their problem. So, for example, imagine you're an operations manager, you've got a process that you know that there's a blockage in, you think that if you bring in computer vision, my blockage will suddenly be solved. That's not how computer vision works. Think of computer vision as a way to get more data onto that process, so you can then leverage that data for insights as to how to solve the blockage. So computer vision won't actually do the solving. Someone in your organization will need to do that, but computer vision will give you the insight into where the problem is and information around it contextually that enables your change management team to then go and deliver whatever it is to leverage those insights. So computer vision, I kind of think of it as three parts. There's initially data collection, capturing all of that data, then the insights, so understanding that bit about teaching computers to see and understand, and then operationalizing.
Yeah. Yep.
That's a good start, isn't it, guys? Which is then taking those insights and delivering actual change into the business with them.
No, that's perfect. Thank you. And what kind of manual tasks do you think are kind of ripe for computer vision to replace or augment?
People ask us this all of the time.
Yeah.
And when we are asked this, one of the things we say is like, is there a process that you are visually inspecting?
Yeah.
And that's usually right for computer vision. So imagine you are a health and safety person who's walking the floor looking for health and safety infringements. Or imagine you are a QA person who is manually checking for defects or for damage or for checking that processes are being adhered to. Or you are an operations person who has a process that you're checking from a productivity analysis perspective or from a process flow perspective. All of those people who are on site visually inspecting something, they're usually a great place to start for computer vision.
Excellent. Okay, so let's talk about computer vision in action. Can you maybe walk us through a real world example where there's been a kind of clear business impact for that organization?
Yeah, so I think if we stick potentially in the manufacturing space and also with a sector that I was previously talking about in QA process adherence. So we work with a large manufacturer in the US who produces a high volume of a product that you need to do your day-to-day life, so a product that you rely on. If they ship bad product because of the volume, they could have shipped a lot of bad product. Or if you are a customer who receives it and then you can't go about your day-to-day life because it doesn't work, that's actually quite high reputational damage. So when we spoke to them about why they needed to know their QA processes were being adhered to, they said a large part of their production line now in manufacturing is happening in machines. And when it happens in machines, you can write programmatical checks, you can have different code that's written in there to make sure that the machine's working as effectively as possible and that it's being as reliable as possible. Not a whole of their process was being run by machines. There were still humans and a human element to their production line, and you can't programmatically check a human. So they felt that they didn't have oversight of everything that was happening in that area. Computer vision enabled them to check 100% of what those humans were doing every day. They felt that they were able to reduce the risk of human error by having that oversight for the computer vision, and off the back of that, able to detect any QA process infringements, which will enable them to see any products that potentially might not be working as you were expected, and you can then check those shipments before they're sent to customers.
Yeah, super interesting. I mean, we obviously see a lot of different use cases. It might be worth you sharing some more details on how computer vision has been applied more thoroughly to quality inspection, defect detection, etc. What changes have you seen it bring to the business?
Yeah, so if you think of anyone with a large warehouse, supply chain, manufacturers, retailers, anybody basically who's got a whole load of stock that they're shipping, they can't, without computer vision, manually check everything. So usually they'll be doing spot checks of, say, 20% of the shipments that come through the warehouse, making sure that they aren't damaged, they aren't defective, that they're in good stead. Computer vision enables you to check 100% of stuff that goes through your warehouse. So you have cameras on gates, you have cameras within the warehouse, checking for damage on pallets, damage on parcels, and automatically flagging any of that to people on site, quality inspectors, but also automatically logging it in your systems. It can also be detecting which parcel it is, so you can be logging in your system, parcel 123 has arrived damaged, you know you need to send another one. So damage detection there has the benefit of reduced oversight because you don't need someone doing those spot checks, but it also has the increased volume of the percentage that you're able to check. So if you think about the number of damages that you're currently identifying in those spot checks, multiply that to if you're checking everything, just think about the volume that you'd be able to identify before it reaches your customer.
Yeah, definitely. Another one we often talk about is health and safety. So why does that function have such early use cases?
Health and safety is a great place to start with computer vision. You're detecting things that are really clearly visible through cameras and are also usually really clearly visible through CCTV cameras that you might already have. Health and safety people can't be on site all the time. And they do worry that when they are on site, potentially behaviours change. If you know you're being watched, you're going to follow the health and safety procedures. So as a health and safety manager who can't be on all of their sites at all times watching everybody, how do you know that your processes are being adhered to when you're not there? Computer vision gives you the ability to do that. Yeah. If you also look at like the historical data that health and safety teams had, they would know the incident records or the injury records. So they know when someone has been injured. But they don't know what's the context around that. They don't know what near misses they've had. They don't know what risk of collisions they've had. They don't potentially know what risky behaviours are happening on site that can potentially lead to more near misses. So computer vision enables health and safety teams to get that wealth of data which sits around that incident record. So not just this is the number of people who are injured, this is the number of people who are injured, which is hopefully zero. These are the risky behaviours that led to that, and this is the number of incidents that didn't happen as a result of near misses. So you can have targeted training, you can identify peak times, you can identify shift working patterns. There's just so much that you can do when you open the door on all of that data.
Yeah, it's brilliant. I actually really love to see those use cases in action.
Yeah.
I know you have a quick video to share with us, so maybe you share that now, talk us through it, and maybe talk about the things that you would like people to notice in this.
Yeah.
That's great. Really good. So let's move on to the implementation phase. So for companies just getting started, what is that first step? And why do those first steps matter so much to getting it right?
Like I just mentioned, that one was a good one, as it was 2 cameras that just go to a siren. Start simple. Like if you've never done computer vision before, it's probably not about to solve the biggest problem in your organization. It might help you to solve that in the long run, but don't start there. Start somewhere where you're going to be able to set it up in 6 to 8 weeks, start to deliver value, and then move on to another application or scale the one that you've got. So take a business problem that's important and identify some baseline data so that down the line you can determine whether or not computer vision has had an impact. So if we go back to one of the use cases we were just discussing, if you know that you have 7 forklift incidents in a warehouse in any given month, implement computer vision and then detect whether or not that's trending up and down over time. Hopefully what you'll see is that once people know that you're tracking it, you'll start to see behavioural change and you'll start to see that incident number falling. You'll very quickly be able to showcase that value back to your senior team. You can then, once you've sort of dipped your toe in the water. That's an English phrase for anyone who's not English. Once you've dipped your toe in the water, you can start thinking about more complex projects.
Yeah, that's great. It's all really, really good advice, actually. So how about the company's data strategy? How important is it? And are there any kind of best practices when setting up cameras and collecting data?
Yeah, well, like I said at the beginning, some organizations already have a large camera infrastructure and you don't want to have to invest again. Like if you've already installed CCTV across your organization, that's a great place to start. We can leverage those cameras. Potentially you might need to reposition a couple or add a couple of new ones, zoom in, zoom out, but you're essentially looking at an infrastructure that's already there. Ideally, they'll be streaming into a video management system. So anyone who isn't aware, a video management system is where you record all of the data from your CCTV, and that has already got a wealth of data in it where you can start training your first model. You just export the detections that you're looking for. Before you know it, you're off to the races and your first application's done. If you don't have cameras and a video management system, it's okay. Computer vision is usually detecting things that are quite large, like excavators, forklifts, people, pallets. So any regular CCTV camera, as long as you're starting with a simple use case, will be usually good to go. You pop up the CCTV camera, you can start collecting data within the first couple of weeks. One of the main problems with this is more that people are overthinking it. Just put up a camera, start collecting data. If you ping it across to us or anyone else, they'll be able to tell you whether or not you can detect what you're trying to detect.
Yeah. Well, let's talk about tech choices then, shall we? What should teams think about when selecting a computer vision solution?
Yeah, so in our experience, computer vision runs most effectively when it's on the edge.
Yeah.
There's a couple of different reasons for that. One is privacy. You don't want to be streaming people's faces or people's identifiable information anywhere to the cloud or storing it if you don't have to. But second is latency. If you just think about the time it takes to stream to the cloud and then push information back down again, if you've got someone who's about to be hit by a forklift, you want to tell them straight away. Yep. You don't want to wait for that loop. Yep. And so it works best when it's on the edge. That then leads inevitably to the next question that people ask is, what device do I need? Thinking again, start simple applications. If that's where you're starting, which is what we'd recommend, you can look at like 3 main topics, which is what's your environment? Where are you putting it? If where you're putting it is where you would normally put a computer, you can buy a standard computer. If what you're looking at, a standard edge device. If what you're looking at is, I'm on a construction site, it's muddy, it might rain, you might need something that's ruggedized and prepared for that kind of environment. Cameras. How many camera streams are you expecting this device to process? Essentially, the more camera streams that you've got, the heavier the amount of data that it's going to need to process, the heavier the device is going to be. And then finally, your budget. So do you need enterprise grade? If you want enterprise grade, are you going to pay for enterprise grade? Or can you start small with a gaming computer type edge device, which will enable you to just get up and get going and then prepare for the enterprise later?
Perfect. So how do you approach that pilot phase? And what are those kind of must-dos to make it successful? What should they be doing always?
A good and effectively scoped pilot will deliver value within 6 to 8 weeks.
I knew you would say that. I knew you would.
Ideally, you've already set up for your long term. So what does the long term of this application look like? Are you building one simple application that will enable you to repeat, and it's going to be repeatable and scalable to lots of different locations? Or are you building the first application that's going to enable you to create like a smart hub of a warehouse, if you like, where you're going to build more and more applications and deploy it to the first location, and then you're going to scale afterwards? So a good pilot will know what the scaling looks like and what that route looks like. It will be well scoped, it will be a simple application, and it will ideally be detecting larger objects like people or forklifts or excavators, where you can get up, get going, and iterate later on.
Brilliant. Yeah. And you touched on scale there. So scaling is really important. So when it is time to scale, what are some of those kind of common traps you see companies fall into? One
of the things that, there's 2 common traps. The first common trap is waiting on your hardware. Hardware installation is what takes the longest in this game. I don't really know why, but it takes people a long time to install edge devices. And so don't get behind that. Like, know that your location is going to need an edge device, get the IT team on board, get them purchased, get them installed. The other thing that people think is going to be an issue is the model fine tuning. I don't know why people have in their heads that it takes a lot of time to train and fine tune a model, but they seem to think that iterating on a model is a negative. Okay. It's not. You can iterate on a model within sort of 1 week of collecting data, 1 week of annotating it. It can be trained by the week after and you're ready to go again. Yeah. Retraining and fine tuning your model is just going to make it more accurate and better at whatever it is that you're trying to do. Like, there's not a massive time drain. Don't stress about it. It's just something that has to be done to deliver results.
Yeah, brilliant. And I guess change management is huge in these projects. Any tips for getting team buy-in and adoption across organizations?
Yeah, well, like I said at the start, computer vision is not going to actually do the solving. It's going to do the data collection. And then once it's given you that wealth of data that you've never seen before, you're going to be able to get some insights out of it, which we can help you with. So like how to quantify that data and see the change that needs to be made. But then that final piece of operationalizing requires buy-in from the organization. So once you have your list of what needs to happen, someone's going to need to go and make that change. And so at the point that you're bringing in computer vision, you should be ready for, like, if we're going to start analyzing this process, we're probably going to start identifying bottlenecks. How at the end of that, have we got the resources to change those bottlenecks? Or are we just going to start tracking a process, getting insights in it, and never actually making any change? So computer vision is the way in, but operationalizing is the end. And if you're going to really see value, you have to take that data and bake it back into your organization.
Yeah. Sounds sensible. If you had to pick one mistake then that you see a lot with across the industries, different industries, and how would you avoid that? What would it be?
So waiting before you deploy.
Okay.
I see a lot of organizations, particularly innovation teams or R&D teams, wanting to like play around in the lab scenario. They spend a long time training models. They sort of theorize application logic. They end up like overscoping a project. And then when they come to deliver, they find the real world scenario is potentially not as they had perceived it to be. And they think that they've got further down the development track, closer to production. But in reality, the real world is going to throw so many complexities at your project that you're no further along than if you'd have just started. So the main thing I would say is just like get cameras up, get a device fitted and start collecting data. And then you can build your application off the back of that afterwards.
So getting stuck in is absolutely the best policy.
Yeah.
Brilliant.
Stop planning.
Just do it. Okay. So when companies are evaluating computer vision solution providers, what should they be looking for then? What should be important for them?
Well, as I just mentioned, you're probably not going to plan for everything that's going to happen. Like, there's going to be real world conditions that you haven't anticipated. And so you need flexibility. If you think that you can scope everything at the first, define all of your criteria and then deliver and you'll just get results without ever having to change, that's probably unlikely. And so if you don't give yourself the room to be flexible, to change your application logic, to change your camera positions, to look at detecting different things, to look at different rules and push to different areas of the organization, if you don't have that flexibility, you're going to be stuck with an application that probably isn't fit for purpose in the long run. So that's something that I'd caution. The other thing that I'd caution is being told that it's going to work straight out of the box. The reason you need flexibility is because you're going to need to iterate to work out what's right for your organization and to future-proof yourself. And because you need that flexibility, it's likely that it's not going to work first time. When I say it's not going to work, it's going to work. It's going to detect things, but your accuracy level and the impact that you have to your organization will not be as high as theoretically it could be. So don't be scared of model training. Don't be scared of tweaking application logic. It can be done iteratively, delivering back value as fast as possible.
Yeah, great. So essentially work hard to solve for what you need to solve now, but make sure you have the ability to kind of prepare for future challenges and other use cases which will inevitably crop up, right?
Yeah, so you want like the ability to build new use cases. You want the ability to tweak logic for different plants. So, for example, the health and safety rules for one plant might be different to another plant. You want the ability to tweak for different camera angles. If someone moves your camera, you want the ability to slightly tweak your model to still do a detection. So just get going.
Get going, yeah.
Yeah.
And I guess it's easy to expect perfection kind of right out of the gate. Why is that iteration you talk about so important here?
It's a trade-off for timing. So basically the question is, do you want to deliver value back to your organization in 6 weeks or 6 months?
Yeah.
You can spend 6 months in a lab and you can train the perfect model and you can build the perfect application and feel like it's going to drive lots of value for your organization and then deploy it into the real world and still face challenges.
Yeah.
If you can just get going, deliver the first iteration within 6 weeks, even if it's not working perfectly, if it detects 6 forklift near misses that you never knew had happened, you're still delivering back value to stakeholders as quickly as possible. It also means that like if you're iterating in like 2 to 4 week sprints, by month 3, you've gone through 3 rounds of iteration and you're probably pretty close to what you want. And so in my experience, getting going will lead you to reaching your end result of a perfect application faster than staying in the lab for longer and fine-tuning.
Yeah, absolutely. And so just probably finally, how does the model evolve over time and how do you make sure that it really truly is adaptable for you?
Yeah, so at first, it will be very used to the camera angles that it's looking at. So it will be almost overfit for what it's seeing. The more different camera angles that you add in, the more different conditions you add in, the more different light, the more different weather, the more different everything, the more variance, the better. And over time, it's going to get better at what we say generalizing. When it's better at generalizing, it means that it will detect more effectively in an environment that it hasn't previously seen. So early on, what you're trying to do, it's like teaching a baby, you know, when you teach a baby by telling it lots of words, like you take it apple, you take it pear, you take it raspberry, so that when you say blueberry, it kind of knows what a blueberry is. It's the same with your model. You're going to show it this camera angle, this camera angle, this camera angle, this camera angle. So when it's shown this camera angle, it might already have a pretty good baseline. So that's the reason that you want it to generalize.
Perfect. Well, this has been some excellent stuff today, Abby. Thank you so much. So audience, I'd love to now invite you all to submit any questions you might have. And maybe if I can welcome Talia back. I think I saw some questions coming in already. Have you chosen which ones you'd like to put to Abby today?
Yes, and great job, both of you. That was an awesome session. I saw a couple of questions come in. And so the first one, which we actually get a lot for Abby, how long does it usually take to go from pilot to production?
It depends how prepared you are. The largest holdup is in hardware installation. Usually that's because it takes people a long time to procure devices and it takes a long time to get them fitted. If you can get over that hurdle, a site can be up and running in anything from 6 to 8 weeks, which means around month 3, you can be ready to move on to site 2. That usually means you've done around 3 iterations on your application. You're pretty comfortable that it's going to be fit for location 1 and for location 2. If you've not got your hardware fitted and you're working out what to buy, it's going to take you a little bit longer.
Awesome. Then the next one that I'm seeing is, what's something you're excited to see next in this space?
What I'm excited to see is I feel like we are on the cusp of this being a normal way of working in some of these spaces, particularly in the health and safety space. I feel like within sort of months to a year, it will just become normal that everybody is detecting forklift near misses using computer vision. It will just become the standard. And I'm excited to see how it gets baked into company processes as that happens.
All right. Thank you for that, Abby. And that looks like that's about it for now.
Okay, brilliant. Thank you. So actually, just to wrap up, Abby, maybe one last quick question from me. If people are going to take away one thing from today's session, what should it be?
It's not as complex as you think. Like, just get a camera, start detecting things, and pretty quickly you'll be on your way.
Terrific. Okay, well, thank you so much for your time today, Abby. It's been a great session together, and I'm already looking forward to our next one, which you can see on the screen now on the 25th of June. This time around, Abby will be focusing on high impact computer vision in supply chain, and she'll also be talking about a bunch of real world applications and how to drive ROI from those. So I'm looking forward to that. In the coming days, Talia will be sending out a recording of this webinar, plus details of how to register for the next one. And once again, just thank you all very much for your time today, and we look forward to seeing you at future events. So goodbye for now.
Thanks, everyone.
Thank you.
Bye-bye.